Hello, everyone. My name is Venus Izadi. I'm a specialized solution architect here at Red Hat. And today I want to kind of demo Red Hat Advanced Cluster Security for Kubernetes for you. I will talk about a high level overview and the architecture of this product. But if you are interested to understand a little bit more in the theory and kind of get more deeper into the concept of the ACS, feel free to watch the other recording that I recorded before, just going through the high level presentation. This is more going through the technical part. All right, so from now on, I'm going to use the word ACS instead of Red Hat Advanced Cluster Security for Kubernetes, just because that's shorter and easier to pronounce. All right, so before I start, I just want to mention if you need to know one sentence about what ACS is and what does it do, you just need to know this sentence, that ACS is a Kubernetes native security platform that is protecting your workload during the build time, deployment time, and runtime of your workload. And it can run in all major cloud and hybrid platforms. You do not necessarily need to have your workload on OpenShift. It can be on any Kubernetes platforms. All right, so knowing that, let's move on and talk about the Red Hat offering of where does it stand in the Red Hat offering. So this is Red Hat Advanced Cluster Security for Kubernetes that I'm going to show you today. It's part of the Red Hat OpenShift Platform Plus subscription, and it also comes with other product like Advanced Cluster Management for Kubernetes, Red Hat Quake Container Platform, and OpenShift Data Foundation, which is about managing your data. But today I'm only going to focus on this ACS for Advanced Cluster Security for Kubernetes. All right. Oh, I'm sorry. The business values, this is just one slide. I want to highlight the business values that ACS can bring into your business. It can easily lower your operational cost because it has a consistent visibility and management of security issues, and you don't actually need to learn new and additional controls. So it will kind of enable your team with a consistent, visible tool. It will be able to reduce your operational costs because it has the built-in controls to orchestrate and enforce policies in your environment. So you don't even have to rely on any additional components in your environment. And another point is it can increase the developers' productivity because you're giving them an earlier feedback. So you can actually have tools like ACS during your pipeline, and when they're building their product or their software or before the deployment, they can capture all these security issues, and they don't need to wait through the whole life cycle of the software before it deployed to the or pushed into the production to find out about those security issues. So it will increase the developer's productivity for you. This is, I think, this is my favorite slide. It has like all the different touch points for ACS. It shows that the ACS can be run during the build time to secure your supply chain, like when you're building your software, during the deploy time, which like before the deployment into the environment, or actually during the runtime, which means that like it will detect all the suspicious behavior of your containers during the runtime, now, which is very powerful. But and these boxes, the gray boxes down there, it will show that ACS can easily tie into different image scanners, so you don't have to use StackRox if you don't want to. It can tie into different CI/CD tools. In the CI/CD tool, you can make it notify or kill the build or kill the deployment, etc. Like whatever you want to do, you can do that as your CI/CD process. But you can easily inject ACS into your CI/CD tool. You can also help you with sending notifications to your ticketing system like Jira or whatever system that you're using. For example, you can set it up in a way saying that only notify me if you see any vulnerability with the CVSS of 9 or anything else. You can also tie into different system information and event management, like Splunk if you want. And the last part, it's very important to know that it works with any Kubernetes distribution. So you don't really need to have OpenShift. I mean, you need to have at least one OpenShift cluster. I'll talk about this during the architectural talk conversation. But your workload doesn't have to be on OpenShift. It can be on any other Kubernetes distribution that you want, and it can run anywhere. It can run on the public cloud, private cloud, or hybrid multi-cloud. Let's have a very quick overview about the architecture of the ACS. I'll leave these notes here so you can read them if you want to as well. So when you're installing ACS, and this is for any Kubernetes distribution, so not necessarily OpenShift, you will have two components: central services and secure cluster services. These central services, this is the part that I mentioned, that it has to be installed on the OpenShift. So you need to have at least one OpenShift cluster, and any other workload or any other cluster that you have, you can just install this Kubernetes cluster, secure cluster services on top of your cluster, and it will be secure your workload on those clusters. Central services has two components: one central, one scanner. Central is technically the UI, the portal, the interface that you're using to capture all this data from ACS. So that's the thing that you're interacting with. And the scanner is just the image scanner, like you are capturing all the vulnerabilities by scanning the container images, and it will report to the central, to your UI portal. As I mentioned, this is only it has to be on OpenShift. So secured cluster services has three components, and as I mentioned, it can be on any cluster: sensor, admission controller, and collector. So collector, as you can see in here, it says like on nodes, it can analyze and monitor all container activities on your cluster nodes. And it will collect all the information, network activity, your container runtime, all the data that it needs to. It collect them and it will transfer them to sensor. And because collector does that for all the nodes, now at this point, sensor has all the information about your cluster, so it can analyze and monitor the cluster for you. And also it can trigger the deploy time or runtime violation based on the policies that it's been defined for it, right? And admission control, it has all these policies, and it prevents users from creating workloads that violate those security policies for you. The same story in any other clusters that you want it to be secured. If you have the secured cluster services, they will have the same components. The only difference, if you are like using any other Kubernetes distribution versus that you are installing ACS on OpenShift container platforms, the only difference would be this little slim, lightweight scanner that would be on the OpenShift clusters. So it will just, it's very lightweight, and it will scan the vulnerabilities of your container images. And as we talked about this before, everything will be reported to central. One little note about these third-party systems, I will show this during the demo, but it's important to know that your ACS can be integrated to lots of third-party systems. It can be as part of your CI/CD pipeline, as I mentioned before, or any logging, email, event management, or your own container registry. We'll talk about this during demo in more details, but this was a high level of architecture of the ACS. And a very quick note, because that might be important to you. Some of the projects, that open source projects that Red Hat is involved with, is one of them is the StackRox project, which is the upstream project for ACS. The kubelinter which kind of analyze Kubernetes YAML files and Helm charts, and we're going to use that for scanning operators. We're using Claire, which is a static analysis of vulnerabilities, and we're using Falco, which is a runtime security. And as part of like developing ACS code base, we are contributing to Falco code base a lot as well. All right. Let's jump into the demo. All right, so this is my ACS, or Advanced Cluster Security for Kubernetes platform. Let me fix this issue. All right. So as you can see, I try to keep everything like not complicated, high-level review, and I will show you all these little tabs and every details. But to start with, I will start with this top right panel, which has my user profile, like the details of my account. It has information of the API. It has cluster health. The health of the cluster shows the components that I just talked about, the collector, sensor, admission control, and scanners are okay or not, or healthy, they're working and running. And also if you have multiple clusters, it will all show all of them. Right now for this demo, I only have one cluster. That's why I only see one of them here, the production one. You can switch to dark mode if you're planning to interact with ACS through the CLI. You can download it here. And this search bar, this is the part I wanted to show you something. It helps you to quickly find information in this console. For example, if there is a CVE out and you want to see if it's affecting you or not, you can easily come here and search for that. So this is the CVE number. You search and you realize that 4 of the deployments and 4 images have been affected. You can view this on the risk tab or the violation tab. I'm not clicking on that right now because I don't want to confuse you, but I will walk through the risk and the violation tab separately during this demo. I just wanted to highlight that you can use search for stuff that you are interested to find out if they're affecting you or not. Or other thing that you may want to know is that is there any root access privilege for any of your containers or your images? And you can say like 6 images will give you the user root access, or in 4 of the deployments that's already there. So it just gives you more understanding about if you're looking for something, you can easily search that in here. The navigation menu that I will show you later. Let's go back to dashboard. On this top left, you can see the information about all the clusters, how many clusters you're observing right now, the number of nodes, how many violations, deployments, and images and secrets are there in this cluster. So technically, you're just having a visibility about like what your cluster or like what ACS is kind of monitoring at this point. I want to walk through all these widgets in this dashboard, but as part of that, I'm going to show you the tabs here as well. All right. So the first widget, it shows about the violations in your system and it's sorted by severity. For example, right now it shows like 5 critical violations already in your system. I'm going to click on that to see this top 5 violations, and it will take me to this violation tab on the left side. First of all, violations are the you can say like these are the records of a specific time when a policy criteria were met, or like when and if you can translate it as an event that is already happened in your system and violated your policy. So one of them you can take a look at is like this policy has been breached and it was not enforced. It means that like it didn't kill the like for this instance it was a runtime life cycle, which means that it was captured during the runtime and it didn't kill that deployment of this specific image or container because it was not enforced. You can click on it. This is the time that it happened. You can click on that and get more information. And like, for example, this shows that how many times it's been happening. This is a specific violation. We can go through these different tabs to show like what more information about this deployment that this violation happens on, and the policy. So what was the policy that you set before that this specific event violated that? Just a quick note that this part guidance always gives you some guidance about how you can prevent these violations in the future if you're interested to do that. But it's just like a kind of little help for you to make sure that it's not going to happen again. All right, so now that we know that, we'll go back to the dashboard again and we go for the next section because we understand like what violation by severity means now. The other part that it shows is images at most risks. It shows like the images in your environment that are risky. I'm going to click on the view all. It shows all the images that you have and they're risky, and it sorts them based on the risk priority. If you can see at this column, it shows like these few ones are like having the risk priority 1. It means that they are very risky. All right, so these are the images, the image name and URL. It shows the CV. For example, this is specific sample has 281 CVEs and 153 of them are fixable, which kind of gives it a 9.8 rating, which is a very high, which means that you need to address that in your earliest time. This is the time of the creation, the last scan time, and it shows the image of the operating system, and it shows if this image is active or not. So right now this image is active, and it shows this like defecting deployment. For example, for this specific one deployment got affected and 97 components. And by components, we mean layers of Docker. When we are creating an image, we are adding different layers of components on top of each other to create that image. And in here, it means like 97 components. If I click on that, it will show all the components of this specific image. All right, I'm going to click on one of these. I want to see if I can get more details on that. It shows this summary of this image. As we talked about it, it shows the risk priority. It shows the rating of the CVSs, all these little details. I'm not going to go through all of them, but it shows that, for example, this is the part I was talking about, this Docker file. This is the Docker file that's been kind of this image is based on, and these are all little layers and components of that. And in here, you can see, for example, this specific component has 31 CV. So if you want to start with one of these components, you you can start with that. And it gives you all this information, by the way. If you click on that, it shows you the information you can read through and get some more understanding of what's going on with that component. All right, so, and also like it has, this CV has been observed for this image. So you can go through specific CV if you're interested to get more details on that. It's just a different way of like digesting the CVs for this specific image. And for the ones that I like, some of them, it just shows they're fixable. You can also go through and open that in full tab to get more understanding of what the CV is kind of talking about. All right. This is the part of the images, and you can of course search if you know the image, and you can search here and just find out what kind of, based on the name of the image, based on the CVE, or how, like whatever you want to search for. And just a little note for this risk priority of these images. It's very helpful for the team because it can kind of help them to prioritize the work and just only focus on the ones that they need to be fixed very, like, as soon as possible. All right. The other section is deployment at most risk. Let's view all and see what we can find here. It shows all the deployments in your environment that they are risky. For example, the first one is a visa processor deployment that we did. It is in the cluster, in the production cluster, and it shows the namespace as well. Like, so this is a specific cluster, specific namespace. So if you want to go, if, like, for example, you have lots of clusters, so many of namespaces, you can easily find which application or which deployment we're talking about. Again, it shows it based on, it's sorted based on the priority. So you have a chance to kind of sort them and go through them based on the priority. I'm going to click on this, and it will show you the details of why this deployment is considered as risky. So for example, it shows all these details, the policies that we violated, excuse me, the image vulnerability, and all this sort of stuff to go through and make sure that these are the reasons that this deployment considered as a risk, as a risky deployment. One little note here is that, like, look, this is very important. This service, like this deployment service with a processor, has been granted cluster admin privilege in the cluster. So if attacker managed to kind of get access to this deployment, it can have an access of your whole cluster, and like, because it has an admin cluster, it can do damage. So you can go through all these ratings and understand why this is a risky deployment. It shows all the deployment information as well. And it shows this, so maybe let me choose something else, another one, because I want to show you about, I want to talk about these running processes and the baselines, and this one is valid. So let me see. So in general, maybe I just talk about it. I'm sure it should be fine. So in general, ACS by default is going through to the content and create a container baseline for you, which means that for your deployment, it says that all these processes are okay to be run during inside this container, inside this deployment for this deployment. If you want to change that, you can easily click unlock the process thing, and for example, remove this process from the baseline, which means that from now on, I don't want this bash to be run on this specific deployment. sometimes ACS would detect some running processes that they are not in the baseline, and it will highlight it as a red. So this box would be a red box, and it will says that, hey, I detect this process which is not in the baseline, and do you want me to add it or just take action? Either add it or remove it, or just let me know if it's a risky thing. But it gives you the visibility to decide on that. And one more thing here is when you, for example, you want to say this bash, I don't want this bash to run on any deployment, on any processor. So what you can do, you can actually create a policy here. So you're going to search based on the, let me find out the exact thing. So you're going to, for example, filter based on bash and say, oh, like these 4 deployments are kind of letting this bash run into their containers, right? But I don't want any containers do that or any deployments do that. So let's create a policy here. I just click that little create policy from the top right button. You go through the policy details and it will actually let you create this policy for that. Let's do this together. I name this policy no bash allowed. I make it high. I give it a category of like anonymous activity. The description, the rationale, and guidance. These are like the stuff you can add on to give more information when actually someone breached this policy and they're violating that. So it will help them to understand and help them to resolve that easier. You can relate this kind of attack to whatever you want. You can assign a life cycle stage for it. You can say, for example, during the runtime, I don't want anyone be able to run this bash command. So I will leave it for runtime. So I will, for this event source, I will leave it to deployment. You can make sure that it's just informing you about this violation if it happens, or you can actually say inform and enforce, which means that if you see someone's actually trying to do that, kill the deployment, kill that process. And you can enforce it, for example, during the runtime. It's like if the container is running, is an active deployment, and someone's trying to actually run this process inside any containers, just enforce it, just kill it during the runtime phase. And for the criteria, you can just choose whatever you want. Like at this point, I just say that it's an unexpected process executed, but you can design that however you want. You can scope this policy saying that, for example, in this cluster specifically, it's okay, or during this namespace, for this specific namespace or for this specific project, it's okay. Like my containers can run bash, but any other clusters or any other namespaces are restricted. You can scope that here. I'm not going to go do that for now because I only have one cluster. At the end, you will go through the review. This would be the policy that you just defined, and you save it. All right. So if I go through this policy management in platform configuration tab in here, it shows all the policies that are available for my cluster right now. Lots of them are already defined, predefined by ACS, like their default policies that ACS defined for me. For example, this 30-day scan age or 90-day image scan age, which are already defined and enabled. But if I go here and say, for example, this policy, and I'm looking for bash, the one that I just created, you see that it is already there and it's enabled because you just enabled it. The severity is high and you can edit the policy if you want. I'm going to go through, click on that very quickly, and you can see that it's exactly how we defined it. Going to back to this policy management, in here you can see each policy has description. It shows they are either enabled or disabled, what the severity looks like, and which life cycle they are belong to. And that's the important part because you need to make sure that the life cycle has been set. And yes, that's pretty much it for these policies at this point. But if you want, you can create a policy here as well. So you don't have to go through the risk and then create policy. You can just easily come here to the policy management and create your policy exactly the same way as we talked about before. All right. Going back to the dashboard, we talked about the violations, the risks, deployments as risk, and images that they're aged. I mean, we talked about this. This is the kind of images that already violated the aging policy. But just a quick review. If you click on that, it shows you that what kind of problems are going on with this specific image. Oh, and one more thing is when you click here, it shows you the deployment and CVEs, the components, like these related entities. It could be useful for you if you can click on that. Like, for example, I click this, it means that this image was found in one deployment and this is a deployment. And you can click on that and this is the information of this specific deployment. All right, so going back to dashboard, policy violations by category. We talked about the policy violations, but let's go and click on that. As we talked about this before, this is a violation tab. It just shows the violations that kind of happened during the scan and gives you more details about what this violation was about, what the deployment details are, and how you can kind of make sure that you can remediate this for future containers. So in here, the policy, it says that the guidance can be, if you want to fix that, you need to rebuild the container. All right, going back to the dashboard. Oh, so in this is a very important tab talking about the compliance by standard. Doesn't have the data yet. I'm going to the compliance and scan the environment, as you can see on the top right, to get some information. This is showing the standard compliance already available out there. So it kind of shows reports and gather information from the configuration, industry standards, and best practices for your containers. I'm not going to go through all of them, but just a quick review of these are already the standards out there. I can show you, for example, this NIST 800 190. It shows the details of that. You can view the standard. This can be very useful for security team because it gives them lots of information and visibility about what the environment looks like. You can see, for example, for this specific compliance, I'm just going to collapse all of them. It shows like all these are all the criteria, all the information for each one of them, and how much of that has been met in your environment. For example, for this one is 100% met, this is 0% and 0%, and these two can be items that you can take action on. And of course, you can read about these compliances in a different tab. All right, going back to dashboard. Now that I gathered all the information, it shows this numbers and these details on the dashboard. All right, so we talk about all this information here. I think I forgot to mention this, that you can kind of adjust your dashboard based on the cluster that you're using. Right now we are having only one cluster, so it's a production cluster. I can just click on that and it will quickly filter all the information based on the cluster that I use. Same for the namespaces. I can just choose like few namespaces and it will show me the data, the related data for the images, policies, violations and policies and everything for those specific namespaces. That gives you a very clean view of everything, what's going on in your cluster or namespace. All right, so talked about dashboard, we talked about violations, we talked about compliances, we talked about risks. Now I want to talk about vulnerability management and show you how kind of you can handle that. So technically, vulnerability management is it's a tool you can detect the vulnerabilities early on in the software lifecycle and work to resolve them. It gives you the visibility of that. So this dashboard, I think most people are familiar with like data like this. On top, it shows you a very quick overview of what's going on. For example, it shows like 8 policies, 3 of them are failing, the number of CVEs, how many nodes are involved, and etc. And in here, we can filter based on like the cluster, or you want to see all this information only for a specific namespace. And maybe sometimes you want to see only the fixable CVs. So if there's something that you cannot fix, maybe you just don't want to see them at this point. I'll show them all. So this is just shows them in a visual way that what's your critical vulnerabilities and kind of show them how critical they are, so you can kind of prioritize working on which one, on the top riskiest ones. In here you have the top riskiest image. You can kind of filter based on the top riskiest images or components or nodes. But for now, I'm just going to click on the view all. And it takes us to the very familiar dashboard as showing the images. All right. Let me search for the image. What was that? The visa processor. This one. So this is the image I want to dig down and get some information about, for example. You can see, for example, it has all these CVEs related to that. We talked about this. I will click on this CVE because it says it is fixable. I want to get more details on that. It's affecting 5 components. Let's click on that. Excuse me. And yeah, so it gives us all the information that we want for it and how we can help to remediate this kind of problem. If I want, like, this could be kind of the process that we want to do. This is a CV, and I want to say, all right, so it is fixable. I want to defer it for the security team to review. I want to defer it for 2 weeks and for all the tags involved with this image. And the reason I want to do that, because it's been fixed in the new release, next release. And I click request approval. So this will go to the team if they want to review, to the security team. They can review that and they can accept or reject it. But it will kind of a part of the process that you can say that you want to defer that, or you want to mark it as a false positive, saying that, oh no, we don't have this. All right. So in the next section, which is a risk acceptance section, the security team can come in and say, oh, this risk has been marked as a deferred risk, saying that, oh, it's been deferred. There's one comment here. It says it's been fixed in the next release. And if they go through the details and they agree with that, they can approve it or deny it or cancel it. And then it will show all the approval and the false positive ones in these two tabs. So that could be as part of the process of what the security team would go through. And the reporting, as always, it's a really great idea to create a report, automatic report, give it a name, for example, whatever name you want to do, the weekly scan report. You can make it weekly on a specific date, describe what this report is all about, and it will show you all the fixable, for example, CVEs that happened during the last week. And only maybe you can say only critical and important ones. But you're defining the scope, you're making sure that it's setting up in a nice way, for example, via email, or if you want to integrate it with Slack or any other notifier, you can use that. That's a great tool for security team to make sure they're on top of everything. All right. We talked about the vulnerability management as well. We talked about policies. We created a policy and we showed that it was enabled. Let's see what else we can do. Did we show the compliance? Yes, we should talk about compliance. The network graph. So in general, like network segmentation is the way to show how you are controlling your traffic, like how the traffic flows between different parts. If, for example, the traffic stops in one part, you can, for example, understand like there's a bottleneck or there's something that's going on, or if anything happens in one segment, you don't want this to happen in the other segment. So that's why you're applying the network segmentation, and it improves the cybersecurity by limiting how far an attack can spread. That's the whole idea around it. In this tab, let's see if we can have a good understanding of that. I'm choosing the cluster. I'm choosing the namespace, for example. I just want to see the workflow in the backend namespace and all the deployments. So it is, as I mentioned, it shows all the segmentations, different segmentations, and the flow. For example, in here says that this backend Atlas deployment has one external flow and one internal flow. And it will just give you the information, for example, as a missing policy for this old traffic. So OpenShift by default, when you're deploying, it has a default to no egress and ingress restriction on any namespaces. This is very useful when you're working with the proof of concepts, but it's not a really best practice for production or for your, like if you're going through the compliance standards. That's why it's always a good idea to create policies for your network segmentations. So for that, you can actually like read all this information for your flow, understand what the flow looks like. By default, ACS creates this as a baseline. For example, say that it's okay that these ingress and egress ones are like valid ones. But again, as always mentioned, you can mark this as a you can include that or exclude that from your baseline. And your network policies, for example, you want to create a network policy, which is, as we talked about, is very important. What you can do, you can just come here and click on the simulate network policy and click generate and simulate network policy. And it will create this policy from all your network activities. And that is pretty much everything. It was a high level, and like we quickly touch on everything. Like these are just all the items that you can also go through um, for yourself on your own time. That the system health, the configuration of the system, the access control. You'll have you can, as always in any Red Hat products, you can always have the access control defined for users, what roles they can have, what permission they can have, and oh, this integration part that I wanted to talk about. If you remember, one of the slides that we talked about was this one, that you can integrate your ACS with different image scanning, registries, CI/CD tools, and etc. Right? This is the part that you can actually go ahead and integrate your tool with ACS. For example, if you have a registry like, let's say, I'm looking for JFrog Artifactory. Maybe that's something that you want to use for your container registry. You just click on that and you will start going and integrate that with your ACS. So this would be the integration part, easily done with ACS or any other one. Policy management, we talked about this, what the policies are. These are predefined, defined by ACS. You can define your own, of course, and the health of the clusters. That is kind of the summary of everything I wanted to talk about for ACS technical demo. Please feel free to reach out if you have any questions, or if we can help you with setting up, or any way we can help you. One last point that I want to touch about is how you can install ACS on your cluster. This is the OpenShift cluster that I have. You can use operators on your OpenShift cluster, easily install the ACS on your cluster. You just come to the operator in your admin tool. You come to the operator hub, search for ACS or Advanced Cluster Security for Kubernetes. You click on that, and I already installed it. That's why it just shows uninstalled, but it would be as simple as just clicking the install. And when you do that, you can go to the install operator, and it will show it here. It shows that this is the cluster. And if you want to create central or secured cluster, this would be the page to do that. This is the way to do that on OpenShift cluster. But if you are planning to do that on any other Kubernetes distribution, we have a documentation at Red Hat documentation profile that you can just go ahead and see if you are meeting the requirements, and just go ahead and follow the steps. It can be installed very easily. It's not a very complicated thing. All right, thank you again, and looking forward to hearing from you. Thanks.